Hey everyone, and welcome. Today, we're going to tackle one of the most fundamental and powerful design patterns in Go, the decorator. Seriously, if you want to write flexible, maintainable, and idiomatic Go, this is a concept you absolutely have to get your head around.
All right, let's just jump right in with a scenario that I'm sure this feels a little too real for some of you. You've just inherited a critical service. Maybe it's a payment processor. It works, it's been tested, and touching it feels like you're defusing a bomb. But now, product comes knocking. They need new features, logging, auditing, maybe some fraud detection. So how in the world are you supposed to add all this stuff without risking a massive production outage?
Well, you could just dive in and change the code directly, but yeah, that's incredibly risky. You could try to subclass it, but come on, this is Go. We don't have classical inheritance for a very good reason. And rewriting it from scratch, who has time for that? This leaves us with the fourth, and frankly, the most elegant option, the decorator pattern. It lets you wrap your code, extend it, and ship it, all without ever touching the original.
So what is it really? The decorator pattern is basically the architect's secret weapon for extending code that you can't or just plain shouldn't modify. Think of it like this. It's a way to attach new responsibilities to an object by putting it inside a special wrapper that handles all the new stuff.
And this right here? This pattern is the open-close principle in action. It's the literal embodiment of it. Your code should be open for extension. You can always add new features, but closed for modification. You don't have to change code that's already working. The decorator pattern is what makes this elegant idea a practical reality.
Okay, so to really make this click, we're not just going to stare at code. First, we need a mental model, a really simple one, but a super powerful one. Let's build the blueprint by thinking about this in layers.
The absolute best way to picture this pattern is with a set of Russian nesting dolls, Matryoshka dolls. The tiny doll in the very center, that's your original object. Every doll you place around it adds a new layer, a new feature. So when you interact with the biggest, outermost doll, you're actually triggering a chain reaction that flows through every single layer all the way to the core.
Now, this whole thing only works if you follow three, let's call them non-negotiable rules. First, everything, the original object and all the wrappers, they've all got to speak the same language, they have to implement the same interface. Second, each decorator has to hold on to the object that it's wrapping. And third, the decorator does its own thing, adds its own logic, and then, critically, it delegates the call to the object inside it.
All right, that's enough theory. Let's get our hands dirty and look at some code. We're going to see how this blueprint actually translates into practice. We'll start with a fun little example, pizza, and then we'll see how this exact same idea powers massive production Go servers.
First up, let's build a pizza. We'll define a really simple interface for adding an ingredient. The pizza base is our core object, and every topping we add is going to be a new decorator. The whole point of this example is just to see the moving parts of the pattern, nice and isolated, without any other noise. Okay, take a look at the code here. This is our blueprint in action. See that meat struct? It has a field of type ingredient add. That's rule number 2 right there, embedding the interface. And then look at the add ingredient method. It does its own thing, it adds the text, meat, and then, here's the magic, it calls the same method on the object it's wrapping. That's rule number 3, delegation. That simple structure is the entire engine of this pattern. Okay, let's graduate from pizza to production. I am not exaggerating when I say that the single most important use of the decorator pattern in the entire Go ecosystem is HTTP middleware. And the core interface for all of it is the standard library's HTTP handler. And here it is, out in the wild. Our logging server is a decorator. See how it holds a field called next of type http.handler? Sound familiar? Then in its serve HTTP method, it does its job, it logs the request, and then it just passes the request right along by calling l.next.serveHTTP. If you've used Chi, Jin, or Echo, you have used this pattern. This is how their entire middleware system works.
Now let's quickly clear something up that trips a lot of people up, especially in interviews. That's the difference between the decorator and the proxy patterns. They can look kind of similar at a glance, but they're used for very different reasons.
So this table lays it all out, but here's the real takeaway. It's a trade-off between safety and flexibility. A proxy gives you compile time safety. The compiler checks that it implements the entire interface. It's rigid, but safe. A decorator, on the other hand, is all about runtime flexibility. You can build these chains of functionality on the fly, which is incredibly powerful, but it means you lose some of those compile time guarantees.
You know, the coolest thing about this pattern is that once you know what to look for, you start seeing it absolutely everywhere. This isn't some abstract academic idea, it's a core building block of Go itself. You're probably already using decorators every single day, and you might not even realize it.
Just look at this list, all from the standard library. When you call buffio.newReader, you pass in an io.reader, and you get back another io.reader that's been decorated with buffering. When you call gizib.newWriter, you wrap a writer and decorate it with compression. http.timeoutHandler wraps your handler and adds timeout logic. They're all decorators, hiding in plain sight.
Okay, we've covered a ton of ground. So to wrap this all up, I want to make sure you walk away with 4 key points absolutely nailed down.
Okay, number 1, and this is the big one. 2 things must be true for it to be a decorator. It has to implement the same interface as the thing it's wrapping, and it has to hold a reference to that thing. It's not one or the other, you need both. No exceptions.
Takeaway number 2, HTTP middleware in Go is the decorator pattern. It's the poster child for it. Every single time you type router.Use in your web framework, boom, you are stacking another decorator, another nesting doll, onto the chain. Number 3, and please remember this one. Order matters. A lot. Think about it. If you put a rate limiter before you authenticate, any random person on the internet can hammer your service and burn through your request tokens. But if you authenticate first and then rate limit, now you're only applying limits to actual valid users. That's a huge architectural and security decision. And last but not least, number 4. This all comes back to that open/closed principle we talked about at the beginning. The decorator pattern is how you live up to that ideal. It's the practical, hands-on way you can add features without breaking what already works.
And really, that brings us to the core idea here. The decorator isn't just some pattern you learn from a book. For building composable systems in Go, it's the idiom. Understanding decorators means you understand a fundamental piece of Go's entire design philosophy.
So, now that your eyes are open to it, now that you can see the pattern in the standard library and your favorite web frameworks, the real question is, where are you going to use it? Where in your own projects can you apply this to make your code cleaner, more flexible, and way more robust? Thanks for joining me.